So normally today the reason why I chose this topic, values, expressions, operators, statements, couldn't think of a clever name, so that's what it is. The reason why I chose this is because sometimes I think, especially when you're first learning how to code, sometimes you start to get overwhelmed and lost in the complexity of what you're working on. And I think is really helpful to like go back to the basics, like back to the fundamentals. Because the more you reinforce those foundations, the easier it is to manage those complexities. And so that's my goal today with going over these things. These are like the absolute bread and butter of JavaScript, and it's pretty applicable to other languages as well. But obviously, this is web development, so we'll be focusing on JavaScript. Oh, got another person. So before I go into my thing, I want to ask you guys if you have any questions just right off the bat, because I want to try to make this as useful as possible to you guys. Anybody? All right. Well, once you do have some questions, feel free to speak up. All right. So, share my screen. I'll do this thing. All right. Can everybody see this all right?
Yes.
All right. So like I said, the topic for today are values, expressions, operators, and statements. I don't remember what the order was that I said those in. So we'll just we'll start with values and expressions. So I want to ask you guys, just in your own head, in your own intuition, have you ever wondered this? What is the difference between these four things? Like, do you guys have like a running definition in your head about what these are? Have you heard? I'm sure you've heard them before, but does anyone want to, I don't know, give their hypothesis on what these are? We can start with like a value. Like, what's a value in JavaScript?
Number.
Cool. A number is an example of a value. Anybody else?
A value cannot be changed, or can it?
That's not always true. Arrays are values and they're mutable and they can be changed. So a value is just it represents a discrete piece of information that if I were to like give the elevator pitch on what a value is, that's what it would be. It's a discrete piece of information. And this piece of information can fall into one of several categories. And these are, you are already familiar with these, whether you knew it or not. These categories, which are typically called data types. So the data types in JavaScript are number, Boolean, string, array, object, function, and symbol. We're not going to talk about symbols today, but it is one. So we might as well mention it. Undefined and null. So when we're talking about values, what we're doing really is we're talking about discrete pieces of information that fall into one of those categories. Does anybody have any questions about that? Does that make sense? So
Yes.
it's nice to think about it that way. And so as a software engineer, and as a former teacher, I am very particular about the vocabulary that I use when I'm talking about coding and stuff. I try really hard to be very precise, not just so that it's easier to communicate with other engineers, but also the more precise your language is about this stuff, the better you're going to be at coding, just straight up. So we're going to talk about these data types right now, and they're related to values, but it's very important not to conflate the two. A value is not a data type necessarily. Okay, so it's not entirely accurate to say that a number is a value. A number is a data type. 10 is a value. Okay, the string hello world is a value, but it falls into the category, or it belongs to the data type string. Now, a particular value can only be one data type at a time. So the value 10, for example, is always a number, will forever be a number. It can never not be a number. We can convert it to a string in the sense that we can represent the characters 1, 0 as a string. But they're not the same data type. So therefore, they can't be the same value by definition. Okay, there's true. Okay, that's a value. True is a value that represents the data type Boolean, right? Same, and then, so what's interesting about these data types that we're going to kind of really, I want to really drill down how important this is that every category, every data type, there is a finite amount of, or there's a finite variety of values which can belong to that data type. Okay, so easy question. How many values can be represented by a Boolean?
2.
Yeah, just 2. True and false. Those are it. That's it. There's no such thing as a Boolean that's not true or false, right? But what I want to emphasize here is that true is a discrete bit of information that belongs to the data type Boolean, whereas the number 10 or the number 1.3 or 0 or -5 or 4, whatever, these all are discrete pieces of information that fall into the number category. Fun fact, NaN is technically a number data type, which is confusing because it literally stands for not a number. So just put that in your pipe and smoke it. That's how it was designed, apparently. So now numbers, because a number is just a representation of, the number data type represents like a mathematical idea, concept of a number. There, of course, are a multitude of possibilities for a number, right? Way more than a Boolean. I don't know the exact number, but for an integer expression, I believe it's a 32-bit signed integer. That's 2 to the 32 possible values. So there's a lot. And then you got not a number. Then you have also infinity, which is a data type, believe it or not. Or sorry, it's not a data type. It's a value. It's a number. So again, these are all numbers. These are all technically numbers. And there's lots of possibilities. Strings are, I mean, there's even more possibilities of strings, right? Because there's not like a limit to the string length. Well, in theory there is, but in practical terms, there's just so many possibilities, right? but again, there are only, you're limited by your character set and by memory. Anyways, so strings, numbers, Booleans are kind of the most basic data types that you encounter every day. They're discrete information, and they're represented by discrete pieces of information. There are more complex data types, which we call composite data types. Now, composite data types are represented by, and sometimes they're called complex. To be honest, I've read mixed definitions for these. What makes sense to me is to call arrays and objects composite data types, meaning that they're composed, they're built up of other things. Because you can have an array and you can have an object, but what's cool about arrays and objects is that they can contain other values, right? We can have an array of numbers. We can have an array of strings. We can have an array of Booleans, numbers, and strings. We can build up more complex or more composite data types using arrays and objects. And just as a note, these are typically called, wow, I just spaced it, primitive data types. Okay, so numbers, Booleans, strings, undefined and null, which we'll get to a little bit later, but those are also primitive data types. Okay, so just we'll list them. Okay, so these are your primitive data types, whereas these are your composite data types. And but again, same principle of before, where this array right here is not an array is just a data type, but it can be represented as a value. So the discrete bit of information is this array, which contains 10, 10, the letter A, and true. Okay, so when we talk about arrays generally, we're talking about the data type array, the composite data type array. But when we're talking about a value, we're talking about a specific discrete piece of information. Okay, in this case, it's a little bit more complicated than just a simple true or the string 10. It's a value that is described as a collection of various other values. The key here is that these are values. They're discrete pieces of information, and I'm gonna really hammer that in. Objects, same thing. When we're talking about objects generally, we're talking about a composite data type object. But when we're talking about values as objects, we're talking about a discrete piece of information that is defined by a set of key value pairs. And again, it's just like an array where we can create all sorts of cool hierarchies of information. But however complex they get, the key is that it is a value. So does anybody have any questions about composite data types? Is that pretty straightforward so far, I hope?
Yes.
Cool. Please stop me anytime with questions. I'm happy to clarify. So finally, there's another data type, which I've read it as, or in the resources that I've come across and read, I've read them as complex data types. And a complex data type, an example would be a function. Okay, so if I have some function that says console log hello. So, okay, so here's an example of a data type, or sorry, here's an example of a function which is a member of the function data type. Okay, so again, I'm making a discrepancy, or I'm making a distinction between functions as a general concept, as a general data type, and a particular function, which again is just a discrete piece of information. Now, functions are a little weird because it's hard. What really took me a while to understand was the fact that functions are values. They're no different than an array or a number or a string, in the sense that it is a value. It's a very fancy kind of value. It's a value which you can invoke on demand. I can go like this, and which is, as you know, calling a function or invoking a function. But the function itself, when we're talking about the actual piece of information that represents the instructions that this function does, that in and of itself is a value. Okay, it's a value which happens to belong to the function data type, which we categorize broadly as a complex data type. To be honest with you, I'm not sure what else would fit into the complex data type category. I've seen in different places, I've seen these all grouped together under complex data types. Again, I think it's more, rather than memorizing this kind of stuff, I think it's more important to just understand these. It's just better to just understand how these work regardless of semantics. So to me, in my head, this makes the most sense in terms of describing these guys. So, one thing that I want to point out, so this is all of them. I haven't really talked about undefined and null. I'm going to get there in a second. So one thing that I want to point out, notice how I haven't used any sort of variable declaration or anything yet. I did that on purpose because values are just discrete pieces of information. Okay, when you start introducing variables and stuff, that's where statements come into play. And we're going to talk about that in a minute. But the key here is to realize that these values, all of these things, so undefined, null, 1.3, this array right here, these can all, because they're just discrete pieces of information, we can store them, we can pass them around, we can manipulate them. And so no matter how complex these get, we can store them as a variable. Okay, I can put a const whatever equals in front of pretty much every one of these things. That's what's so cool. Now functions are a little different because this essentially, I could write it this way. Right. And effectively the same thing. There's obviously slight differences between that and a function declaration. But anyways, the key here is that these functions, these objects, these arrays, they're all discrete values that we can store and pass around and manipulate as variables. And so when we're talking about the return value of a function, again, it's return. There's a reason why they call it a return value. It's because a function can only return a value, which means it can only return a value that represents one of those data types. So, any questions about values before we talk about operators? Cool. Oh, sorry. One thing I did want to mention about undefined and null. These guys are kind of unique because while undefined and null are data types, they also they can only be represented by one value, which is themselves. So undefined is a data type undefined, but it also has only one value, undefined. It can't ever be anything else. There's no other meaning of undefined besides undefined. Same with the null. They are not equivalent. They're not the same thing. They are used. the same way in a lot of ways, but they're not the same value. They do not represent the same value, but they are very similar. But they are unique in the sense that they only have one value. And if it's hard to kind of wrap your head around that, just remember that a Boolean can only be one of two values. So imagine a Boolean that can only be one value. Well, that's essentially undefined and null. Okay, so up here, we've essentially basically just like defined some pieces of information that fall into one of those categories, one of those data types. Now, that in and of itself is not very useful. I can't really write a meaningful program with just these. The function I can kind of get close, but still like this isn't a program, right? Like this isn't like doing something. I'm literally just splattering values on the page. So to make programs more expressive and more powerful, we need to be able to do something with these values. So the first thing that we can do is we can add operations. We can add operators. So anyone want to try to attempt a definition of an operator? Along with maybe an example of one? Don't be shy. Go ahead.
So something that operates on a value and changes that value.
Cool. Yeah. The only change I'd make to that is that you don't actually change the value.
Okay. Yeah.
But you can create new values by performing operations on other values. Right? Because we can't change 10. Right. Now, we can change an array that contains things, right? We can manipulate it. So, but again, I want to be careful to say that not all values are immutable and not all values are mutable. Some can be changed while still essentially being the same value, while some are not. Like you cannot change the meaning of 10. We can add numbers to 10 and we can subtract numbers to 10, but 10 will always be 10. And regardless of what we add or subtract to it, we'll get a new number, but 10 doesn't change its meaning because we added it by 1. So, but whereas with arrays, there are things we can do to arrays to, maybe erase a member or add a member or edit a member that already exists. While it's still the same value, it's still the same array, it now has different contents. So we just want to be aware of those things. But yes, an operator is just a thing. It's a symbol that represents a operation performed on one or more values. That is kind of the elevator pitch for an operator. It's just something that can be performed on one or more values. The key is values. Okay, an operator only does things to values. Okay, so what are some common operators that you've probably used a ton already?
All the mathematical operators.
Yeah. So those are the most obvious ones. So we got plus, we got minus, we got divide, we got the mod operator. If you guys haven't seen the mod operator, you will. It's very useful. We've got the, let's see here. Maybe you've seen the plus equals. There's the equals operator. There's the triple equals operator. There's the less than operator, the greater than, the less than or equal, et cetera, et cetera, et cetera. There's all these operators. So the goal today isn't to talk about what these operators do. What I want to do is introduce a conceptual basis for understanding them. so that regardless of what operator you're familiar with or not familiar with, you have a framework from which to understand it with. Different operators do different things, and you're going to learn all the different operators as you get better at this. But the key is to remember that an operator is just something, it's just a symbol that represents an action or operation performed on one or more values. So if it's, so there's three different types of, there's three different types of operators. You've got unary operators, binary operators, and ternary operators. I don't know of any other ones. So unary, as implied by its name, is an operator that is performed on one thing. There aren't very many. Can anyone think of some? Have you guys seen the not operator? Which will flip something from true to false or false to true. There is what's called the unary plus operator, which I know looks, or it is the same as the plus operator, but if you perform it on one number, or sorry, on one value, it tries to convert it to a number. Not many people know about this, but like, for example, if I have this, that actually will convert that to a number data type. But again, the details aren't important. What's important here is that there are operators which only act on one value. That's the key, one value. Okay, so binary ones, we've already mentioned a bunch of them up here. So like divide, minus, greater than, equal than, triple equals, the double equals. I'll list a couple just. Minus, plus, all the mathematical ones. Oh, and multiply, of course. So binary are the most common. There's two other ones that are really important. There's the or operator and the and operator, which of course is kind of like asking an either or an and question to two values. So the key is that they operate on two values, two distinct pieces of information. And what you get from it is a single value. So no matter what these are, whether you start with one or two or three values, an operator is always going to reduce it to one single value. Does that make sense? Just like 2 + 2 is always going to be 4. You're never going to get like multiple values. That wouldn't really make sense. Now you could get an array that contains multiple things in it, of course. But again, an array is one distinct value. It's one distinct piece of information. So that's kind of one of the most important things to understand about operators is that they take either 1, 2, 3 input values, and they output one, just one. Okay, just for fun, let's look at the ternary. There's only one ternary operator, and in fact, it's just called the ternary operator. And it's kind of like a poor man's if statement. That's what I call them, because they're very similar. They're very similar to an if statement, but they're very different in the sense that they're actually an operator. Okay, so they're an actual operator that takes 3 values and outputs 1. Okay. If you're not sure how the ternary operator works, that's okay. That's not the purpose of this talk today. So does anybody have any questions about operators so far? Cool. All this making sense? Beautiful. Okay. So to bring this all together, oh, thanks, Danny. So to bring this all together, we've talked about values and we've talked about operators. Okay, well, before we get to statements, we've got to talk about expressions. So who here doesn't know what an expression is, or does and wants to give it a shot? Is anyone confident enough to give a dictionary definition of an expression? Because that's okay. So this is, I think, a concept that really that new programmers really struggle with, and I struggled with it for sure. So this is why I'm doing this, to try to help alleviate those concerns in the future. An expression is not a scary, complicated thing. Literally, an expression is just a value. Okay, an expression is just a value. All values are expressions. All expressions are values. However, the reason why there's a distinction is because an expression is usually intended to represent a value that has been outputted from some operation or set of operators. Okay, so for example, let's think about the value 10. Okay, so 10 is an expression. Okay, because it's a value. 10 is a value. It happens to be a number data type. Okay. Hello. That is an expression. It is also a value because values are expressions and all expressions are values. This happens to be a string because it is a set of characters in between two quotes. Okay, cool. Well, if we want to really get some meaning of what an expression is, though, let's represent this as something else. Okay, we're going to represent the value hello, but we're going to represent it differently. Now, I'm going to have I have a challenge for you guys. What would be maybe another way that we could represent this value hello using operators? Ever heard of the word concatenate? What if we did this? That's the same value, okay? This is an expression. So is this, but this is typically what's meant by an expression. Okay, it's like an expansion. But again, because we're just using a plus sign operator, in this case, the plus sign concatenator, this is when we reduce this, when we perform all the operations that are defined by the rules of this operator, what we end up with is this value right here. Okay, so these are literally the same value. Okay, that's something that's really important. And I could represent this in other ways too. I could literally break this up like this. Okay, these are all expressions that represent the same value. Now I could get even crazier, and I could say, I could take some array and do all this. It's really obnoxious to type all those apostrophes. Okay, so I could do this, right? Join them all together. That's the same thing. That's the exact same value. All of these are equivalent. And if I wanted to, I could reverse them and then reverse them again. And I have, okay, you get the idea. This is all just these are all just different ways of representing the same value. They're just using operators. So typically when we're talking about an expression, we're talking about a value that is represented by some type of operator, or some value that's the output of some operator. Does that make sense? Now, just to clarify, a function call is not an operator. Okay, so like when we're calling this join method, that's not an operator. That's just a function call. I've found that some people kind of will conflate the two. A function call is just that. It's just a function call. It's not an operator, because a function is an actual discrete value. They're not operators. Operators, they don't have discrete values, right? Like, or they're not like discrete pieces of information. Like a plus sign by itself is kind of meaningless. Like there's no context. Like it's like, okay, well, plus what? There's no information to get from that. But once you start associating them with values, operators start to have meaning, because they have meaning in the context of those particular values, those pieces of information that are being manipulated by that particular operator. So you can imagine how complicated this gets, right? Like once you have operators and values, you can create some pretty insane expressions. And you've probably seen the parentheses where, like, I don't know, we'll say 2 + 4 is less than, and then we'll say the minimum number between 10 and 12, or the max between, I don't know, 20 and 100, who cares, right? Like at a glance, this is kind of confusing to look at. And then we could, of course, put that expression into a right? Like what we can do is we can start composing expressions from very basic sets of information, which are values, which can be categorized into certain data types. So even though this looks super crazy and complicated, this is a single discrete value. To be honest with you, I don't even know what that value is. It's either going to be complicated or simple, literally. But, you know, based on the rules of the orders of operation, let's see, so we've got 6. So basically we got to take these one set at a time. So, okay, we can look at this and say, okay, 6 is less than, and then we look at this and say, okay, well, the minimum of 10 and 12. So, okay, so that reduces to 10. Okay. And then this math.max, that reduces to 100. And then we're using the OR operator between 10 and 100, because 10 is a truthy value. 10 is going to be the result of that operation. So then the question is 6 less than 10? Yes, it is. So it's complicated. Does that make sense? I don't expect it to make sense in the way that I hope that conceptually that makes sense. If you don't quite follow the logic here, that's totally fine. That's not what this is for. I want to get the abstract concept across. So that's operators, expressions, and values. There's one big piece missing though. Even though we have all these crazy cool infinite possibilities now at our disposal with operators and values and expressions, our program is still not very good. There's not a lot we can do with this. We can like paint pictures with values, which is cute, I guess. But our programs don't have a whole lot of meaning. right? So the real power, I guess, that programs need, or let me put it this way. The real soul of a program comes into how you define various processes based on your values. And these are what are statements. Okay, so we're at the grand finale now. We're talking about statements. So a statement is fundamentally different from everything we've talked about. A statement is, if I were to give the dictionary definition, a statement represents a process in a program. It's a delegator. There are different statements, lots of different kinds. But the key is that they do not represent a particularly discrete piece of information. That is the domain of values and expressions and operators. So a statement does not represent a discrete piece of information. It represents a discrete process. So anyone want to take a guess as to some common statements?
If statements,
Say that again.
like an if statement.
If, yep. Any other ones?
Like for.
Yep, for. I'll add else here too, because that's technically a statement.
The loop, or does that be considered one, or is it?
Yep, so for loops, there are different types of for loops. There's like the for in loop, there's the for of loop, which are they're all slightly different. I'm gonna separate these with comments so we can. Okay, we got all of our loops. Any other ones you can think of? There's not really that many.
Mm-hmm.
How about a switch statement? Seen those guys before?
Would try and catch fit in there?
Say what?
Try and catch.
Yep, try and catch, exactly. Good one. There's one more that is the most common one. You're gonna slap yourself when I tell you. What's one you use literally every day?
Console.
You probably did it this morning. Want the answer?
Yeah.
How about var or a const?
Yeah.
That was right. We got var, const, and let. These are statements. So these are fundamentally different than these guys. Okay. Because they're describing a process. So it doesn't really make sense. Like if else by itself doesn't contain any information, right? For like, it's like, okay, what are you looping through? How many times are you looping? These provide the skeleton for your process or for your program, but like they don't contain information by themselves, but they're very, very powerful, but they're only powerful when they're used in tandem with values. And in fact, it's usually a syntax error if you don't use a statement correctly with a value, right? Like I can't just say if, like, what the hell's that? That's not a thing, right? If I want this to work, I've got to inject some values in here. Okay, so now with if statements, of course, it's like asking a true or false question. So I can do if true, I can do if false. But the real power of statements, or the real power of all this is when you realize that, oh, an expression is just a value. So I can put whatever I want in here, anything at all, any value that can be interpreted as a true or a false can be put there. It doesn't matter how complicated. Like I could literally put this entire thing in here, right? Because it's just a value. It's just a value. It's a stupid value, and it doesn't make any sense, but it's a value. And that's where statements combined with values basically give you programs. That's where the magic happens. When they're together, they're like Stockton and Malone. Like they kick ass. So, does anybody have any questions?
So would function, like the actual keyword function, be considered a statement then? Like if you're declaring a function?
So not really, because the reason why is because I can store a function as a variable. Right. So I can say, like when I'm doing function hello, this is a value. I can go like this. Now this is again kind of nonsensical, but I do this to illustrate the point that this is a value that can be thrown around. I can wrap it in a variable.
So, but in that particular instance up there, function hello, function is telling hello what it is, right?
Yeah, it contains the definition.
Okay.
It contains the block, which defines the code inside.
Okay.
And I can put statements in here, of course.
Sure.
Obviously I can do this. But it in of itself is not a statement because I can throw it around just like any other value.
Okay.
I can wrap it in other things. I can even like if I have some I can even define this like in line with another value. So for example, like if I have some callback function, such as like an event listener, like let's say I have some button and I want to say event listener, right? And I say, hey, click. I can literally do this.
Mhm.
Clicked. Right? So I can't do that with statements. I can't pass statements around because statements don't represent discrete pieces of information, whereas this does.
Gotcha.
Yeah. But that's a really great question. That also confused the crap out of me for a while. Now, when you say this though, so like if let me go back to here. This though, however, is the statement.
Right.
Right. I'm it's not, it probably doesn't seem as obvious because I think processes like if and for are more intuitive in our minds. But this still follows that same exact pattern. We're saying, hey, follow this process, take this variable and set it equal to something.
Right.
Right. Because I can't just like again, I can't say if and then say const test equals true, right? Like that doesn't, I can't do that because I can't pass statements around like that.
Right. Yeah, that was kind of what brought up my confusion on that, whether function was or was not. Because if you're setting const just sets a variable equal to something.
Sure.
But even though I see functions not setting an actual value to a variable, so it makes sense.
Yeah, like, and it's weird because it kind of is a variable. I mean, like it is, it's just not defining it using
Right.
the variable statements. So yeah, that one's tricky.
Yeah.
For sure. But once you remember the rules of statements versus values, you can kind of arrive at that conclusion that, oh no, this is just value. It's not a statement. So for the last little thing, I want to talk about some of the subtleties in all of this. Now, to just kind of recap where we've gone so far, we talked about values and data types, and how a value is a discrete piece of information that belongs to a particular data type. There are at least 3 different types of data types. We got primitives, composites, and complex data types, but they're all represented as, or the primitives are numbers, Boolean strings, undefined and null, and symbol. Whereas composite data types are arrays and objects, and complex data types are represented by a function. Okay, cool. So, and then an operator is just a symbol that represents some operation performed on one or more values, which of course outputs a single value. And then statements are just definitions for a process. And there are a multitude of them. Well, not a multitude. There's less than 10 total, I think, in all of JavaScript. But let's talk about some subtleties here. And I want to talk about the subtleties in operators. This is where I think people get really hung up on stuff. I know I did, so hopefully I can help you guys avoid the same kind of like miscalculation or misunderstandings that I had. So operators are a little weird because depending on the data types involved, they can behave differently. It's a subtlety that is not obvious whatsoever. So when we're talking about when we're talking about the expression, for example, 10 plus 10. Okay, if you're looking at that, let's say you've never coded before in your life. What does your intuition say about that expression? What would that value be?
People normally say 20.
Yeah, and it's a reasonable thing to think. What is it actually?
10 and then a string of 10.
Yeah.
Yeah, it's literally the string 10 10.
Yeah.
Right? It's just
Okay,
it's this.
10 times, right? Or
Oops.
Yeah.
oh, okay.
Yeah, it's this.
Okay.
And I'll prove it to you. Let me go to my sometimes I like to open up a blank console in Chrome anytime I'm trying to like test out little trinkets of ideas.
If you move that operator like one spot over to the right, could you make it be 20? Where you were talking about how like if you put that operator next to the string.
Like you put
Oh,
another
yeah,
operator
yeah,
into the array.
yeah. Yeah, let me show you. Okay, can you guys see this okay?
Mm-hmm.
Okay, so this, I like doing these little exercises in Chrome because you can see the answer immediately. So, okay, so 10, of course, is just 10. And if I add 10, we get 20. Okay, great. If I do 10 and I do 10, I get the string 10, 10. Weird. Okay, now, so your question was if I do, how in your head, how did you want me to write it?
10 and then a space operator plus sign 10 as a string.
Like that?
Yeah, as the string though.
As a string though. Yeah.
Oh, I see.
Okay.
So the problem here is that space
Need a-
is not appreciated,
Yeah.
or it's not really even noticed.
Need a second operator.
If you wanted that to work the way you think it is, we have to remember that this right here is because there are two values on either side of it, the JavaScript parser assumes that that is the binary operator. So if we wanted to do what you're saying, we need to remember that, okay, well, there's the binary operator, which adds two numbers together, but then there's the unary operator, which converts something to a number. So if we want to get the outcome we want, we actually have to use both of them. So what we can do is we can do that.
Got it. Okay.
Make sense?
Yeah. Yeah. No, that totally makes sense. I was
Cool.
just trying to, what you were talking about earlier or previously, I was trying to figure out how that would kind of implement. So
Yep.
perfect.
Yep. And that's, there it is. So the plus sign, I think, is one of the more intuitive. It's one of the more intuitive ones, because even when you add strings together, it makes sense that it does what it does. And even though it's maybe a little like unexpected, once you see this 10 plus 10 string plus number and you see the outcome, you can still, I think, intuitively be like, okay, I guess that makes sense. But the question is, okay, well, why does it do that? In other languages, this would not even be okay at all. This would throw probably an error, and especially in like in the old days, like this kind of thing was very looked down upon. But JavaScript, for for good or for better or worse, it actually tries to do some work for you. And what it does here is that every operator, regardless of what it is, anytime you feed it data types that don't really seem to be what you would normally use for that particular operator, it will try to do what's called a type coercion. It's a fancy word that you can use around the table to sound smart. I highly recommend doing it if you're having a bad day. Anyways, type coercion is just this idea of putting in different data types to an operator and having the operator essentially convert those values to a different data type and then outputting the result of that operation. Okay, so in this case, if you ever feed a string to the binary plus operator, it will then coerce, it'll coerce everything to a string. So with numbers and strings, I think it's intuitive enough, but this is weird. Like, what the hell is that? Does that, if you think about it though, what do you think's happening?
It's just counting it as a value, really. So
They're counting them as a single value.
single value, yeah.
Well, they already are single values. True is
Okay.
just a value.
Yeah.
We're adding two trues together and we're getting two. I'm going to give you something else, and I think this will give you guys a hint about what's happening. I'm going to add true and false together.
Well, it's just.
What's
I
happening?
guess you could probably. Can you
True
add like one
equals to-
word?
Is it the value of true is, well, not the value of true, but the value of true is 1 and the value of false is negative.
Oh yeah, gotcha. Yeah.
You're close. You're
zero.
close. It's not negative
Okay.
1. False is coerced to the number value 0.
0.
Oh, okay.
Okay, so if I add false plus false, I'm going to get 0. Okay, if I do true, or let's do false minus true, negative 1, which is weird. Like, that's weird.
Yeah.
But it makes sense when you realize that, okay, operators, if you feed them values that are like not what you would typically think to use to that operator, the operator will do what's called a type coercion. And the rules governing type coercions are different for every operator, and it's also different depending on the values that you put in. Now, I don't recommend trying to go and memorize every combination and possibility. I don't know them all, to be honest with you. I was playing around with some today, and I realized that I need to look some up because this tripped me out. The hell is that? But then if I go like this, so I'm gonna look that up because I don't know. I tried to like, I know that when you coerce an object or an array to a string, you get that weird object. But why it's different when you reverse it that surprised me. So I got some things to look up. Anyways, my point is that you don't need to go worry about memorizing all the different combinations. Just be aware that type coercion is a thing, and it's a very important thing. And you're going to come across situations where it's important. And so having that seed planted in your brain right now is really good. Now, that being said, I do think that there's a benefit to at least memorizing a couple of these. The plus sign one I think is really useful, but I think you do it enough in your daily coding life that you eventually just know it. The true plus false thing, not so much. That probably threw you guys for a loop. It did for me. But there's other things too, like, okay, what if I do true plus a string test? What just happened there?
Turns out string.
Seems like anytime you try to operate on something and a string, it turns it into a string.
It seems to, yeah.
Yeah.
And I think that is correct. Now, if I do it backwards, let's see if I get the same thing. Yep. So it coerces that to a string. Okay, cool. Now you can, if you get bored, feel free to play around with all these guys. It's kind of fun to try to divide test by an array. You get not a number,
Yeah.
which is a number. So that's fun. There are other things like, I don't know, you can play around with, like, look at this. So that gives you true. If I do not 0, that's true. Okay, if I do not 0, it's false. So this is, I want to emphasize the concept of Truthy and Falsey. Have you guys heard those terms before?
Yeah.
Truthy, Falsey. What's your understanding so far? Like, what do they mean? What does it mean for a value to be truthy?
It can be close to it, I guess. If it's looking for a certain number, it could kind of be close to it, and it'll.
Not quite. Has nothing to do with numbers necessarily.
I guess the only falsy values are null and undefined, and everything else it's truthy, right?
Close.
But-
So truthy, so if something is truthy or falsy, what we're really talking about is what is the behavior of a value being coerced to a Boolean. That's what truthy and falsy means. Now we're going to talk about the rules that govern truthiness and falsiness. But I think it's important to understand that when we're talking about truthy and falsy, all we're talking about is a type coercion from some value to a Boolean. Just like we were talking about earlier with strings being coerced to numbers and numbers being coerced to strings, they behave differently. But again, there's only a finite number of data types. So it shouldn't be it's not too difficult to see how all this works together. So a truthy value versus a falsy value just has to do with type coercing something to a Boolean. So let's think about what those options are, right? So this is my list of data types. That's it. There's only what? 1, 2, 3, 4, 5, 6, 7, 8. There's 9. There's 9 data types. Okay. So that means that whatever value I have, it's going to be a member of one of those. Okay. So if I want to type coerce a number to a Boolean, let's think about the options. It's actually really simple because there's only one of 2 possible values it can have, right? It's either going to be false or it's going to be true. There's no other options. You can't convert. There's no other value besides true or false for a Boolean. So that means that no matter what value we start with, we've got to put it into one of those boxes when we type coerce it. So now, luckily, the rules governing type coercion for Booleans are very intuitive. And all you have to remember is this. If you try to perform some sort of Boolean comparison operator, such as not, or less than, or greater than, or less than or equal. Also, if you try to put something into an if statement, whatever expression you put in there will also get coerced to a Boolean. Anytime you're in a situation where an expression is going to be coerced to a Boolean, you only have to remember 5 things. 0 will coerce to false. Null will coerce to false. Undefined will coerce to false. Empty string will coerce to false. And obviously false will coerce to false. And then that's it. So that's all you got to remember. 0, null, undefined, empty string, and false. Any other value will coerce to true, and I'll prove it. So if I put the not operator on a 0, I get true. If I do a not operator on null, I get true. If I do the not operator on undefined, I'm going to get true. If I do the not operator on empty string, I get true. And obviously, if I put the not operator on false, I'm actually going to get true because, well, it's not going to type coerce false, right? False is false. So if I do not false, that means true. Does that make sense? Mm-hmm. And then, so a couple of things that you will encounter is this would seem to be truth or falsy, right? It would seem that empty array would coerce to false, but it doesn't. So you just have to memorize that list right there. If it's an empty object, nope, sorry, empty object is truthy. Empty array is also truthy. And that is probably the most important type coercion thing that you should know going forward as a developer. Some of these other weird subtle ones, not as important because they honestly don't come up that often. And a quick note on the triple equals versus the double equals. Triple equals are literally checking that they are the same value. Okay, whereas double equals are checking whether they are the same type. So if I do 0 equals 0, that's true because when they're coerced, they're the same value. Whereas if I do a triple equals, that's false because the number 0 is not equal to the string 0. They're not the same value. Any other questions?
No, not a number is falsy too, right?
Oh, yes. Good point. So not a number is falsy. I forgot that. You know what? I should have added that to my list. I apologize. There are 6. Well, false doesn't really count in that list. So technically it's still 5. But yes, I should have added not a number to that list. 0, null, undefined, empty string, and false are all falsy values. And I think once you play around with these and like really get the hang of expressions, values, operators, and statements, like you're gonna like instantly, I think, see code differently. It's not gonna look as scary. I always remember being intimidated by looking at like large code bases, or if I was looking at like a tutorial or something, I was usually pretty overwhelmed by the amount of code just on the page. It just felt like a lot. But once I really kind of mastered these concepts, it stopped being scary. And I just can now it's almost just like reading English off a page. And it's just because all of those things are derived from these very basic rules that we talked about today. So yeah, I hope that was helpful.
Definitely.
Yeah, it's good.
Yeah, and I mean, there's a few minutes left if you guys have any other questions. Anybody got questions? Nobody? No questions?
None for me.
All righty. Well, that's all right. Doesn't even necessarily have to be any of this. But and do you guys have any? So I'm coming up with a list of kind of like upcoming code talk topics. I already posted this in the vSchool Slack channel, but if you guys have any suggestions or for topics, things that you would like to you'd like me to talk about in one of these code talks, let me know. I'd be interested to see kind of what you guys are wanting to learn about. So I've kind of been picking these just because these are things that I had always wished that I had someone to tell me about. But obviously, if there's any things that you guys have come up with, let me know. I'd be happy to try to cover it in one of the next episodes.
I think it would be good if you could, whenever you have time to make one on functions.
Do one on functions?
Yeah, they can get a little confusing, at least for me, like kind of when I have to like embed functions within functions.
Yeah,
I was trying to work on the RPG assignment on module 1.
Mm-hmm.
And man, I got lost real quick.
Yeah, so when you've got
all of
like
the scope of all that stuff.
Yeah, you've got like do a thing, and then in here you've got your callback function, and then it's like you call your callback function with things, and you got to define what that function is. Down here, you're like do a thing, and you're like, oh, I'm gonna put my function here, like stuff like that.
Yes, definitely.
Like managing.
Like if you do this, take some points of this character, and yeah.
Yeah, I'd be happy to do functions for sure. I did one on functions, like it was like one of the first ones I did. I don't know if the recording is there, but I definitely want to do that again because functions are like the bread and butter. You know, being good at functions and learning like some of these functional programming techniques make things a lot easier for yourself. So yeah, it's a good idea. But yeah, that's all I got, unless you guys I don't know, want to learn some more stuff.
I'm good.
Cool. Well, next week is going to be on kind of best practices as far as CSS goes. This is actually the first one I've done on not JavaScript specifically, so I'm really excited to share kind of what I've learned about writing like good CSS and not crappy CSS. There's an art to it, and I am by no means a CSS expert, but I do think I know some stuff about making your CSS more effective. And basically my rule is the less CSS I have to write, the better. So, because I hate CSS with a fiery passion. I'd rather just build servers all day.
Yeah.
I do not. I'm just not interested in CSS at all.
I like it. Yeah, it's pretty cool.
It's funny because like some people like love CSS and like they want to make like really beautiful UIs and stuff.
Sure.
And like I'm perfectly happy with a site from the 90s in terms of if I have to build it. Like I don't know, I'm like a function over form guy.
Yeah.
But that's me. That's just my personal thing.
Yeah, it'd be nice to.
If I have to, I can make it look decent, but you don't want me designing your app. Let's just put it that way.
I always get confused on when I should use a display flex and stuff like that, and when I should use a inline grid, or I always kind of like just flip back and forth which one looks better, and
Right.
kind of figure it out on my own. But
Yeah. Yeah, and I found that people tend to not use classes right. Or it's not that they don't use it right, it's that they don't use it to its full potential. I can't tell you how many times I've seen CSS where it's like you have a class name which is being used as like an identifier for like a particular thing, and then you have like all the same stylings repeated over and over and over again. And I'm like, dude, just make one class, just one class, and then just apply that class where it's needed. That's all you got to do, and then you save like 500 lines of code.
Yeah, make some of those utility classes work for you.
Yeah, seriously.
Yeah.
So yeah, that's what we're gonna go over next week. So if you're interested, please come by. It'll be good. It'll be a good time.
Cool.
Word. Well, thanks, guys.
Thank you.
I'll,
Thank you. You guys
see
have a
you
good
next time. Yep.
Thank you.
Peace out.
Thank you.
Bye.